Okay, today we're going to talk about solving fractional equations. Please make sure that you take out a sheet of loose leaf paper if you chose not to print out these notes. To solve a fractional equation, what you're going to do is first find the lowest common denominator of all the fractions. Then you're going to multiply all the fractions by that lowest common denominator. This is going to remove all the denominators. You're going to rewrite the problem and then solve the equation. If there's only an x, it's a linear equation. If you end up with an x squared, it needs to be factored in order to solve it. So if we look at the first example, since I have 3 fractions, I'm going to look at all the bottoms, the denominators. You need to say to yourself, what can I multiply them all by so that I can get rid of the 2, the 6, and the 3. Hopefully you realize if I multiply each fraction by 6, all the denominators are going to disappear. That's the lowest common denominator. So if I focus on this fraction here, I can reduce the 6 to a 3 and the 2 to a 1. That fraction now becomes 3x. If I focus on the second fraction, if I go to reduce it, the 6 cancels the 6, so then I am left with just 5. If I look at the last fraction here, the 6 reduces the 3 and it becomes a 2, so that last one is going to become 2x. Now I have an easier equation to solve. I'm going to just minus 3x from both sides. And then I'm going to divide by -1. So I get -5 equals x. And that's all you have to do. If I look at the next example, again, my bottoms are a 4, a 5, and technically here, a 1. So you have to say to yourself, what can I multiply each of those fractions by so that the denominators, the bottoms, are gone? What goes into a 4, a 5, and a 1? Hopefully you pick 20. So I'm going to multiply each fraction by 20. If I look at the first one here, the 20 reduces the 4, and this becomes a 5. Very important, because I'm multiplying the 5 by 2 terms, I have to distribute. So that's going to become 10x plus 35. If I focus on the second fraction here, very important, I want to make sure I have the sign there also. So here, the 5 reduces the 20 and turns it into a 4. Make sure that you take the sign with it. So this is -4. So -4 times 3x is -12x, and -4 times -7 is positive 28. And if I focus on the last fraction here, it just becomes 20x. Now I have a regular linear equation to solve. If I combine like terms, 10x minus 12x is -2x. If I add my numbers, in this case, I've got 35 plus 28. I'm going to get 35 and 28. I'm going to get 63. And over here I have 20x. So I'm going to add 2x to both sides. I get 63 equals 22x. I'm going to divide both sides by 22, and my answer is 63 over 22. If you want to try to reduce it, you can, in the calculator, do 63 divided by 22, hit the math button, hit enter, enter, and this fraction does not reduce. But if it did, by typing in math, enter, enter, it would reduce the fraction for you. If I look at the next fraction, again, my denominators, my bottoms, are a 5, a 3, and technically a 1. So I'm going to say to myself, what can I multiply by to cancel a 5, a 3, and a 1? Hopefully you picked 15. So if I focus on the first fraction here, the 5 reduces the 15 to a 3, so this becomes 3x. If I focus on the second fraction, remember, take that sign with it. Make sure the sign is with it. The 3 reduces the 15 to a 5. So positive 5 times x is positive 5x. And on the last fraction here, nothing really reduces. 4 times 15 is 60. Now I have a basic linear equation to solve. 5x plus 3x is 8x. I'm going to divide each side by 8, and I get x equals 60 over 8. We always want to try to make sure that it's in simplest form. So in your calculator, do 60 divided by 8, hit math, enter, enter, and this will reduce to 15 over 2. That is your final answer. If you don't like using a calculator, you could always say to yourself, what goes into 60 and 8? And hopefully you realize technically you can divide them both by 4, and that's also going to give you your 15 over 2. If I look at the next example, again, first thing, because I see fractions, I want to make sure that they're all fractions. If I look at the denominators, the bottoms, I have an x, a 3x, and a 1. Since I want them all to disappear, my lowest common denominator here is going to be 3x. So I'm going to multiply each fraction by 3x. If I look at the first fraction, before I multiply, I reduce. 3 times 5 is 15. If I look at the second fraction, again, notice I'm taking the sign, that plus sign with it. Here, my 3x cancels my 3x, so I'm left with plus x minus 9 equals, and 4 times 3x is 12x. 15 minus 9 is 6. I'm going to move the x to the other side. Some of you might want to put a 1 in front of the x. 12 minus 1x is 11x equals 6. I'm going to divide both sides by 11. So my final answer is 6 over 11. And if I look at the last example here, first thing, when you see a binomial in the bottom or two terms in the bottom, lock them together with a set of parentheses. Now, if I'm looking to see how I can get rid of an x plus 2, an x, and an x, the lowest common denominator is x plus 2. Here we have an x plus 2, and here we have an x and an x plus 2. Once again, we're going to reduce each fraction before we try to solve anything. So here, my x plus 2 cancels my x plus 2, and I'm left with 3x. If I look at the second fraction, again, very important, I have to take that sign with it. My x cancels my x, and now when I'm multiplying, what I want to make sure I do is take this sign. So I'm going to do negative 2 times x and negative 2 times 2. And if I look at my third fraction here, I can reduce the x's, and I'm left with 5, and I'm distributing 5x plus 10. So on the left side, 3x minus 2x is 1x minus 4 equals 5x plus 10. I'm going to move the x's to one side. And then I'm going to move my numbers to the opposite side. I I get negative 14 equals 4x. If I divide by 4, again, I want to try to reduce the fraction, so in the calculator, do negative 14 divided by 4, hit math, enter, enter, and technically you will reduce it to negative 7 over 2. Please make sure you write down any questions and either email me or ask me next time you see me.